Okay, well, good morning. Fantastic to be here and hopefully meet a lot of new people today. My name's John. I'm a professor at the University of Surrey, where I lead the Decade Research Centre, the Centre for the Decentralised Digital Economy, and I also lead the Content Authenticity Research Programme at Adobe Research. I want to talk today about provenance, the origins of content, and how tracing the origins of media can help us address two really challenging issues in the age of generative AI. The first, of course, is deep fakes and the fight against fake news. I guess everyone has their favourite motivational slide for fake news. Mine is a photo that I took here almost 10 years ago at the National Archives, a proclamation against false news by King James II. This was in a project called Archangel that we ran here, looking at use of provenance technologies to underpin media integrity in public archives around the world. I'll speak maybe a bit more about that at the end. So certainly fake news is not new. It's been around arguably since the advent of the spoken word. Everyone has been unfortunately lying to one another forever. And certainly visual misinformation is not new either. This is arguably the first fake photo of some cardboard fairies at the end of the garden. The Cottingley fairies caused a lot of debate at the time. Of course, with the advent of generative AI and social media, these problems are accelerated, though. Another big challenge that we can address with provenance is the copyright in AI problem. If deep fakes were sort of piquing the public interest in maybe 2024, where we had over 2 billion people voting worldwide in public elections, then in 2025, it was definitely the issues around content rights that made the news around AI, and particularly in the UK with the public consultation and the events like, for example, the 25th last year, when every major newspaper ran the same front page, Make It Fair, talking about respecting rights holders for their use of their content in generative AI. So what I want to try and convince you today is that media provenance technologies hold the key to addressing both of these challenges. With respect to fake news, why can't we just detect deep fakes? There's a lot of people out there making startups, etc., trying to detect fake content. Well, the answer is that if we try and fight misinformation, only a small portion of that is actually deepfake content, or more accurately, we should say AI content, because you can't actually detect a deepfake. A deepfake is just AI content made to deceive. You can't write a program to tell you if something is deceptive. You can write a program to tell you if something's AI or not. But even still, AI manipulated or generated content is only a small portion of misinformation. If you talk to human rights organizations, they'll tell you that most visual misinformation is actually unaltered content that simply had a different caption stuck on it, has been misattributed to tell a different story. So the intersection is quite small. If you're fighting it with detectors, you're in an arms race against generative AI, and nothing moves faster than generative AI. So instead, we tackle the problem through the lens of content provenance. We've been working very hard over the last 5 or 6 years to develop an international standard called the Coalition for Content Provenance and Authenticity, or C2PA. It has a user-friendly name, fortunately, which is Content Credentials. Maybe some of you have seen the logo, the little CR in a speech bubble, perhaps on LinkedIn, when people post images that have this metadata. It is a metadata standard. It carries a lot of jargon with it. Metadata is called a manifest. It's essentially a cryptographically signed container that contains facts called assertions about the provenance of content, like who made it, using which sources, and so on. And those sources can themselves have manifests, like other images or videos or audio. And so you get an entire provenance graph encoded in this metadata. And this has now been adopted extensively by industry. Adobe put in most of their products. Microsoft Office carries it. LinkedIn display it. A lot of cameras you can buy now put it in. If you've got Google Pixel phone, it puts it in every photo you take in the hardware. I brought along, given that we are at the National Archives today, something, believe it or not, I got on eBay, but it is genuine, honest, which is an indenture. And this is an example of, this is an example of provenance from 1770. And this is how people used to track the provenance of digital assets, in this case, a piece of land. It's sort of cryptographically signed, in the sense there's a signature under here, and it has been signed and sealed using the technology of the day, which is a paper lock and a wax seal. There's a little lead seal here as well. It's been deliberately cut from a ledger in a jagged way, so you can figure out which page it came from. So it's got kind of weak time stamping on it, and so on. And it even tells you what to do, the rights associated with the asset. Today, with C2PA, this is what a signed digital asset looks like. You can drop it into an open source tool like Adobe's got one, but many people have these things, and it will tell you in this case that the image has been taken by a Google Pixel phone, it's been watermarked, I took it. In this case, it's also got a do not train tag associated with it, which means that if you drop it into commercial Gen AI tools, it will refuse to process the image, stuff like this. And the purpose of this technology then is really to guard against sort of people purporting to be you when they generate content. So if I were, say, a public figure and I were to always sign my content with this C2PA technologies, content credentials, then if someone came out, some nefarious individual with a photo of me saying, this is a deep fake of you, John, I'd say, well, no, it's not, because I always sign my content. Show me my signature on that content. I've got instant deniability. And, this could be, broadcasters, France TV, for example, sign their video now of their news broadcast with this technology and so on. Another use case, although no one's doing it yet, would be in scientific publishing. So, for example, one of the downsides of generative AI has been that there's a lot of fake scientific imagery, particularly in cancer research, being published in journals. If you can put C2PA in the hardware of cameras, then why not in a $500,000 microscope? And perhaps people might start looking for this in some of the content under review. So it sounds great, but actually there is a problem, and that is, of course, that metadata is very easy to strip of content. And unfortunately, pretty much all social media platforms do strip the metadata away. So if I were to take an image and post it up on X, for example, and then I wouldn't see these content credentials, although there are some platforms like LinkedIn starting to do it. Therefore, we have to reinforce the metadata with some other technologies, and these are content re-identification technologies. One is fingerprinting. I think this is a technical room, so we call it perceptual hashing maybe. This is essentially distilling a signature from the image, so that if I take this generated image shown on a display, take a photo of it, I can, using that digital fingerprint, basically look up the missing content credentials, the metadata, and display it. I can also use watermarking. So if I have a browser extension, I could have it scan the images for an invisible watermark that's been embedded in the image, which is essentially a unique ID that lets me go look up the missing metadata. And these types of re-ID technologies create what we call durable content credentials. I won't go into it today, but these three technologies, metadata, the cryptographically signed manifest, C2PA, and these two recovery technologies, fingerprinting and watermarking, all have their pros and cons. We wrote a paper on this. The citation doesn't seem to be showing, but it's called To Authenticity and Beyond. It's in IEEE CGNA in 2024. And basically, we talk about there's an optimal way of combining these three technologies to kind of mitigate their different weaknesses and create a really solid provenance layer. But that is really just the start. We think that these three pillars of provenance enable not only a solid provenance layer, but then enable subsequent use cases that can build on provenance. I've talked about authenticity, but actually we can go further and start attaching signals to content such as rights, like do not use my content for training AI, or even licensing conditions, so that when people do find content, they know who to pay and how much. And this is kind of a capability stack that can be built on provenance. And this idea is something the government is even advocating for now when they talk about this creative content exchange, which is essentially a way to create a platform for licensing content for AI training. We think actually we should go a little bit further and create a decentralized content exchange, because particularly the creative industries, over 60% of their GVA is created from freelancers and SME, small enterprises. So they don't have the big sort of collections that the Creative Content Exchange in its current form, which is essentially targeting cultural heritage institutions, including the National Archives actually, and their large collections. It doesn't quite translate the same way to the creative sector. I'll just briefly touch on some of those capabilities in that stack. I showed at the beginning an example of how you can use the technology for opting out of AI training. obviously, a lot of people here will be aware of robots.txt as a kind of an opt-out tool traditionally used for opting out of search engines scraping your website. It can also be used to indicate don't use my content for AI, but it has a big disadvantage, which is that it's bound to the location. The website doesn't move with the content as it's reshared online. Obviously, content provenance in a durable form does. And we see this as a really useful way of indicating AI opt-in or opt-out markers, because it's a machine readable marker, it's interoperable, it's an open standard, and that means, of course, that there's low adoption because there's no IP associated with it. What it doesn't have at the moment is a legal standing, and of course we know there's a massive debate at the moment around copyright law and the potential to reform it around opt-in or opt-out indicators. But basically, we need open standards for machine reading, opt-in or opt-out for it to make progress in this area, ideally with legal support. We ran a workshop basically looking into creator attitudes to this. It turns out the creators actually want much more kind of complex arrangement than opt-in or opt-out. If they opt out, they want no to mean no and stick with content as it moves online in the way I've described. But if they say yes, then actually they don't want to say just, yes, use my content. They want to say, yes, you can use my content for this purpose and actually quite like to be paid. In other words, they want content licensing. And we wrote this report called Time to Act, which has had quite a bit of policy impact around this idea of using provenance for markers. I'll skip the technical approach, but it's essentially a multi-layered stack, rather like the diagram I showed before. Finally, we built a prototype of this idea. It's not just reports and frameworks, it's actually kind of implementation. We built a system whereby a user can basically discover content online, read the watermark, look up the provenance, and then read licensing information from inside the assets they found in order to create an agreement with the rights holder. Video doesn't play in the deck, so that's fine, I'll skip. Basically, this is using CTPA for provenance, but it's also fusing it with ODRL, which is another open standard, this time for describing content rights. And without going into the detail, one of the things that we've sort of rigged it up to do is if I license an image, but that image has been made from several ingredients in the way that CTPA can express that provenance as being, then actually residuals can be cascaded down to the rights holders of those ingredients as well. So an entire kind of automatic payment system with residuals can be implemented through this system, all by reading a watermark of an image that's been found on social media. So why is this of importance? Well, you know, the UK obviously has AI at the heart of a lot of its growth strategy. Realistically, the AI doesn't, there isn't really at the moment a sovereign AI capability in the UK. No one in the UK or even the EU actually can train a state-of-the-art foundation model. It's the reality. It's all kind of US and China. But what we can do is create a lot of innovation around fine-tuning AI models, or with what's called either supervised fine-tuning or post-training, basically using smaller amounts of high-quality data to create specialist AIs, and this is where 99% of the kind of innovation is coming in this space. This means there's a massive market for high-quality data, like the UK's creative industries can provide, like the UK's cultural sector can provide, that can be kind of licensed automatically through perhaps a provenance-backed licensing scheme in order to generate new sustainable revenue for practitioners. So I sort of conclude by saying that, you know, this story actually began in the National Archives here 10 years ago with the Archangel project, where we first proposed provenance for media integrity in public archives. It's led to the foundation of, you know, the Content Authenticity Initiative, a global standard, and ultimately could come full circle all the way back to the GLAM sector as a way of maybe creating value for it, which I think is kind of cool. Yeah, if they do have any questions, I'm happy to take them. But yeah, basically this is our capability stack, and the message is that, you know, provenance is for a lot more than authenticity. It's also, you know, you can build on it to create decentralized markets for creative content, as long as you embrace open interoperable standards to do so. I'll leave it there. Thank you.